All right. Good afternoon, everyone, and welcome to our session SUP308, Scale Your High Traffic Events to Generative AI Deployments with AWS Support. Show of hands, could you please tell me how many of you have been experimenting with a generative AI solution, like maybe built a chatbot or okay. Almost everybody here. All right, fine. Thank you. Please take your hands off. Now, please raise your hands again if you have taken these prototypes and POCs and deployed them in production at scale. Okay, a few. Significantly less number. Yeah, so we're seeing this trend across the board that there's a lot of excitement, obviously, around the possibilities of GenAI. So customers are experimenting with their use cases. But when it comes to taking these prototypes and scaling them up into production, the pace is very slow. And in this session, we're going to talk about why, and also going to talk about how we can address some of these challenges. But before that, let me introduce myself. My name is Neil Sendas. I'm a Principal Technical Account Manager here at AWS. I'll be joined by my colleague, Mehak Maan, who's also a Technical Account Manager. And we also have a guest speaker from Georgia-Pacific, Manish Sinha. Manish is the Senior Director of Advanced Analytics and AI at GP. So here's the agenda. We're going to talk about some of the common challenges customers face when they take their prototypes to production on AWS. And then we're going to dive deeper into some additional considerations that you need to take when you take your generative AI workloads to production. We're going to see two AWS offerings that can help you along the way. And then we'll hear from Manish about Georgia-Pacific's generative AI journey, how they took their prototypes to production at scale. And then I'll share some additional resources that you could use to learn more about this topic. All right? Let's get started. So I'd like to begin with a few industry statistics. As Gartner reported, 50% of all migration and modernization initiatives on the cloud will be delayed by at least 2 years. So 1 out of 2 deployments and migration initiatives will be, projects will be delayed. One of the reasons for this high number is that as customers migrate their prototype to production, they often underestimate the effort that is involved to take these prototypes and scale it in production. They often underestimate the effort that it takes to take these prototypes and MVPs and make them operationally ready for large-scale production deployments, leading to unprepared downtimes and revenue loss. As you can see, almost 100,000 per 1 hour of downtime. As a result, some of these customers cannot realize the full potential of their investments in these prototypes, because they're constantly working on reactive support mode. And even if they migrated these or scaled those workloads, they also have these technical debts that they need to address even when they have scaled those workloads. So I'm going to talk about 5 common challenges. But before that, as you can see, scale breaks everything. And we are going to talk about how to handle that. And in the next slide, I'm going to talk about 5 common challenges that our customers talk to us about. First, integration with your existing infrastructure. So when you're building a prototype, you're probably working on a sandbox, and you don't have to worry about things like data integration challenges or system compatibility issues or network infrastructure issues. But when you're working on production and trying to integrate these applications, you have to take these factors into consideration. Now, the cloud operations teams have to build a robust cloud operations review strategy to review your resiliency policies and HADR strategies. All those you don't have to worry about when you're building a prototype. Moving on to another area, monitoring and observability. Now, monitoring and observability of your distributed AWS infrastructure across multiple AWS accounts and regions is difficult to orchestrate at scale, because you not only have to identify those resources across your distributed environment, but also set alarms and set a dashboard to manage them centrally through a single pane of glass. Security is, again, one other area that is difficult to manage at scale because you need to identify all these vulnerabilities and attack vectors that your infrastructure is exposed to, and then take risk mitigation steps. Your security ops teams have to constantly review your security posture. As they say, work on security is never done. Moving on to performance. Performance testing in lower environment is never foolproof because you don't have the traffic, you don't have the infrastructure to test it. One of the sure shot ways of testing whether your applications are ready for performance workload is workloads in production is to actually stress test in production itself, which you don't have to again worry about in POC. Finally, cost management. Now this is one area where we have seen a lot of customers overspend because their FinOps teams don't have a robust cost optimization strategy to manage underutilized resources such as your compute, storage, databases. They're also not using the right hardware, and they end up over-provisioning their hardware sometimes. So those are some of the common challenges that every workload pretty much face when you're migrating to or moving these prototypes to production. But let's talk about some of the additional challenges that you need to consider when you're moving your generative AI workloads, because there's another level of complexities that you need to deal with. Although generative AI is based on the fundamentals of traditional statistical machine learning and the neural network-based deep learning, generative AI brings a paradigm shift in how you approach an ML problem. You need to learn new processes such as prompt engineering or retrieval augmented generation. You need to learn new database technologies such as vector databases. You also need to learn how to evaluate models, new models such as embeddings and foundation models. So there's a lot that goes into taking your prototypes to production, and then along the way learn all these new technologies and new systems. So I'm going to talk about 4 areas that need additional consideration. Starting off with data preparation at scale for generative AI. Now, either you use fine-tuned model or a foundation model with RAG. Preparing and positioning contextual data to your LLM is key to LLM's performance. But often these domain-specific data is distributed in your organization, leading to data silos. Now, for example, in a manufacturing industry, you might have your sensor readings in a Pi historian. And you might have your critical documents such as standard operating procedures in a content repository. So you have to take this structured and unstructured data and create a robust data management strategy to manage this at scale and train your models. So you can use services such as Amazon S3 to build a data lake for that, to centralize these data sets. Once you have centralized your data, you'll have to cleanse and validate those data to create a robust data quality standards using services such as Amazon SageMaker Data Wrangler. Once you have cleansed your data, once you have centralized your data and cleansed your data, you have to source ground truth data before you can start training your models. And sourcing ground truth data at scale is, again, something that you have to worry about. And particularly automate this process because ground truth labeling process takes time, right? So automating the ground truth labeling process not only adds consistency to the process, but also removes human biases. And then finally, once you have your ground truth data and you have your output, you have to evaluate the outputs, and that too can be automated to manage at scale. Just talked about ground truth. Let's talk about RAGs. So, well, RAGs enrich your LLM's context, sure, but the way retrieval systems work, it's as good as the embedding models that is used to create these mappings between your data sets. So, and each embedding model has their own advantages. So you have to identify and test with different embedding models and find the one which is right for your use case. Similarly, you have to identify the right vector database for your use cases, and each database has their own pricing and security feature availability, such as role-based access controls. So that's all the things that you need to take care of, particularly for a generative AI workload and preparing the data set. Moving on to another area, MLOps. So once you have prepared your data, now you have to deploy these models at scale. So as you deploy these models across your AWS accounts and regions, you not only have to continuously train, deploy, but also version control these models so that you can deploy newer models and as you train these models. Also, you need to evaluate the output of these models and detect drifts in the accuracy of this model. Not only the model, but also the feature sets. As they drift, you might have to retrain those models using the MLOps pipeline that you created. You could use services such as Amazon SageMaker pipeline for that. And then for prompt consistency, you need to take these, extract these intents and reusable components of your prompt and store them in a template so that you could reuse them, right? Further, once you have quality prompts, store them in a prompt library so that you can reuse those prompts. Amazon Bedrock prompt management is now GA. You could look into that. And then finally, once you have these prompts, you have to continuously improve the content of your library, because as you get feedback about those prompts, you can add new prompts to make a strong prompt library. Further, you need to monitor these LLMs for real-time errors, such as a throttling error, API throttling error, or any kind of errors that can impact your end customer's performance, and you need to react so that your customer's experience is not impacted. Moving on to security and governance at scale. Now, there are additional attack vectors that you need to consider for generative AI. You need to establish guardrails to prevent training data poisoning. Now, if you have training data poisoning, it could lead to toxic data injection and biases. So to prevent that, you need to implement a robust identity and access management policy. Further, to prevent prompt injection, explicitly add security prompts to your instructions that goes to an LLM so that it can avoid harmful instructions that come to the prompt. The age-old DDoS attacks can impact your public-facing LLMs as well. So, the hackers could overwhelm your model with excessive input data or high-volume queuing. To prevent that, you need to, again, validate and sanitize the input data that comes in and have a zero-trust policy to validate who's got access to these data sets. For model governance, you could use services such as Amazon Bedrock Guardrail to enforce data retention policies or manage access to these data sets and manage the model access policies and their patterns as well. Finally, in securing output handling. So, once you have the output coming out of your LLMs, instead of sending it directly to your downstream applications, validate the output, because maybe a malicious intent could insert instructions that might delete a downstream database table or capture sensitive data, PII data. So validation of output is important before you send it downstream to manage insecure data output. Finally, talking about cost management, you need to add financial controls using services such as AWS Budget to manage overspend. Work with your AWS support teams to assess your generative AI operations cost before even you scale it, because there's implementation cost and there is inference cost as well. Also experiment with smaller models, because smaller models tend to have smaller token sizes, which is one of the largest contributor of GenAI operations cost. Further managing your token size, you could have a strong prompt engineering team. Once you have a prompt engineering team that can build quality prompts, it can manage your TPS or tokens per second, which has an impact on your operations cost. All right, so I talked about a lot of these factors. As you can see, there's a lot involved in taking your prototype to production. It would be nice to have a guide that would provide you these best practice recommendations along the way when you move from prototype to production. I'm going to talk about a service that can help you with that. Well-architected framework. So a well-architected framework is a comprehensive guide that cloud architects can use to build a secure, fault-tolerant, resilient, and efficient cloud infrastructure for your applications. It's got 6 pillars: sustainability, operational excellence, resiliency, security, cost optimization, and performance. Now, each pillar provides you a set of design principles, best practices, and questions that you could use to assess your current architecture. And the best part is, you can actually build a consistent approach to reviewing your architecture across your distributed infrastructure. So here's an example. Once you're done with your architecture review, it'll provide you a set of best practices. Here, as you can see, there are 2 security, one security and one cost optimization best practice provided. The first one talks about improving the security of infrastructure by using defense in depth strategy for all your network layers to prevent vulnerabilities and attack vectors. For cost, it provides recommendations on how to use the right resource types, provides recommendations on the sizing, and along with their pricing as well. And with each recommendation, it also provides you a list of AWS services that you could use to implement those recommendations. So with that, I'd like to hand it over to Mehek to talk about another AWS offering, AWS Countdown, which not only helps you with your architecture review, but also helps you transition to production. Mehek?
Thank you, Neil. So Neil has discussed how you can use well-architected framework for your workloads. I'd like to touch on another offering called AWS Countdown. There's 2 flavors of Countdown. So there's AWS Countdown Standard and AWS Countdown Premium. I'll start with Standard. Now, this is a TAM-led offering, previously referred to as IEM, Infrastructure Event Management. So can I just get a show of hands for those of you that have used this offering before? Okay, a few of you, a couple of you. Awesome. So this is a TAM-led offering where TAMs will work with you to anticipate your, someone's just raised their hand a little bit later. Amazing. So Countdown Standard is a TAM-led offering where you can use, the TAM will help you with your pre-event planning and help you anticipate your capacity needs and make resource recommendations based on that. TAMs also own the process of working with service teams to ensure that your service limit requests are considered and approved. So typical business cases that we see customers ask for to use Countdown Standard for, I'll touch on a few of those. It's migrations, so taking on-prem workloads to the cloud, and also product launches. So you could be a gaming customer looking to launch your next gaming series. You could also be a fashion retailer looking to join in on the latest viral trend. The common thread amongst all of this is that customers are looking to handle surging traffic while maintaining performance, cost efficiency, and reliability. With all of this excitement around GenAI, we're seeing customers that don't necessarily have the in-house skill set, wanting a little bit more of a hand-holding approach. And this is where Countdown Premium comes in. It's an engineering-led offering that we can use to support you from your initial architecture to building your POC and eventually taking it into production. We can help you make the tooling decisions and give you prescriptive guidance on developing your runbooks as well. So a typical journey for Countdown Premium engagement looks like this. Day 1, we do the introductions, engage the right engineers, the industry experts, as well as the technical experts for your use case. We can then dive deeper to develop proactive technical guidance and engage the wider team of specialists for architecture reviews. We can also support you expand your in-house skill set with training and enablement. And once we've done the initial architecture and the build, we can help you load test your application to identify any critical parts as well as bottlenecks. And finally, we help you with the go live event. And with that, we can use continuous monitoring using our internal tools, but also help you set up your own tools and provide some context-aware support. And by that, I mean when typically customers raise a support case, the engineer on the other end isn't aware of the context of your use case. However, with Countdown Premium, we can stand up engineers that know what your use case is, what the go live event is, and they can jump on pretty quickly. I'd like to walk you through a reference use case that we developed for a customer who had an initial idea, and we took it to POC. So it was an example of a fashion retailer looking to automate the generation of product descriptions for their online website. So on the left-hand side, we've got the merchandising team uploading the image of a tan leather belt and wanting to generate the product description on your right. AWS SMEs took this from concept to the initial build, and I'll take you through the architecture of that and some supporting design decisions that we made. Now, this is a very overwhelming slide, so let's break it down. We'll start with the front end. So on the bottom left, we've got the user submitting the initial image through the web app, and query goes through CloudFront, which acts as our CDN, to our application load balancer, which is in a private subnet to work as a secure entry point. We also have Amazon ECS running a Streamlit app in a container from ECR, and that's in a private subnet to reduce any exposure to the internet. And then we've got Cognitive for user authentication. We've got the API gateway to help you validate any requests and reject any malformed requests. And finally, we've got DynamoDB, which is acting as a store for our product descriptions. With the backend, we have the step functions workflow in pink. So to generate product descriptions, we need three things. So one, the initial image that the user is going to upload. Second, we need the existing images and some metadata. So that's the S3 bucket at the top. And then finally, we need some style guidelines, which is essentially the tone of your brand. So is the product description reflective of consumer trends, and is it reflective of your brand? And that is processed using TextTract, and we initiate this process by another Lambda. We've got a third Lambda on the screen, which, because this customer wanted to be able to have product descriptions in different languages, so we've got another Lambda to initiate translations. Now, to dive a little bit deeper into the design decisions, with Bedrock, how do we know what model to choose? So for this use case, we needed something called a multimodal model, which essentially just means we need the model to be able to accept images and not just text. We also need to consider for speed and latency. If it's a GenAI assistant, you want the response to be pretty quick. However, there's some leeway with this in terms of speed because it's a merchandising team, not the end consumer using this. And we worked with the SMEs on this project to help us do some technical analysis for different models and assess for different things like speed, latency, and other areas that were relevant. And they were able to get some data presented to the customer and help them make the right decision. Now, thinking about our data strategy, we need to think about it from an input and an output perspective. So for input, we need to consider the format of the data and how accessible it's going to be. So can the user upload the image from a web UI, or is it going to be stored in S3? Similarly, the metadata that we use to train the LLM, we need to consider whether that's going to be public links, or is that, again, going to be something that we store in S3? And is that going to be in JPEG format or another format? In terms of the output, we need to, again, think about how it's stored. This is just a POC, so we allowed the user to be able to export all the product descriptions in an Excel file. And we also need to consider the quality of the output. And this goes back to what I said about the style guidelines. Making sure that it's reflective of the brand and the consumer trends. and our data scientists were able to set a high benchmark and define it for the customer. And where that benchmark wasn't met, we were able to trigger revisions and input the revisions into the next model iteration. We also think about security. So we've already made a number of design decisions that adhere with security best practices. So we're using HTTPS for secure comms between the app and the user. We've got API gateway throttling, which can support the protect against any DDoS attacks using rate limiting. We're using Cognito as well for user authentication, and it integrates with IAM for fine-grained access controls. Now, if we were to take this POC into production, we would need to think about security even further. So we could consider adding geography-aware roles to our CloudFront to allow or block any access to CloudFront distributions where required. We could also integrate with AWS Inspector, so to scan your Lambdas for any vulnerability scanning. And in terms of Bedrock, we'd need to consider some guardrails. We'd need to consider the input of the images. Are those images appropriate? And the output that's generated, we need to think about the language of the product descriptions. Is that appropriate? And how do we make necessary revisions and guardrails so you can implement denied topics that can help you implement those guardrails? We can also, from a Bedrock perspective, consider model invocation logging, which is essentially to collect the metadata, requests, and responses for all of the invocations made in your account. We've got a sample threat model on the screen. So threat modeling is generally a good practice for all your critical workloads, but it's particularly critical for your GenAI workloads. Please feel free to take a photo at this point for the QR codes. I've got two tools, one tool and a resource on the screen. So the resource on the screen is an example GenAI chatbot that has been assessed against the OWASP top 10 for LLMs. And you may be able to use that as a reference material to threat model your own applications. We also have a tool on the screen, which is called Threat Composer. It can help you build your own threat models, and you can build the threat packs as well as the mitigation packs. Now, in terms of regular operations, we need to think about enable logging to track certain errors and metrics. And you can do this via CloudWatch, and we can help you set this up. And we also need to think about cost optimization. So we can minimize the number of calls made to Bedrock using DynamoDB that works as a cache for our requests. So let's say, for this example, the customer had geographic presence in other countries. So they needed product descriptions and translations in multiple different languages. So let's take the example that we have 5 users coming to retrieve the same product description. They can just retrieve it from DynamoDB instead of making the call to Bedrock. In terms of scale, we need to think about can the user upload multiple images at once? In this POC, we allowed the user to upload up until 200 images. And we also allowed them, of course, you can also scale the Lambda functions and set the appropriate limits. And from a Bedrock perspective in particular, there are different limits across different regions. So you need to think about not exhausting those limits. And an example of that could be your style guidelines. If they're super lengthy, you're going to run out of tokens, and you run the risk of exhausting your limits. And also, you can leverage the limits in different regions by enabling cross-region calls. This POC isn't protected data or geographically protected data that only needs to be accessed through one geography, so we can enable cross-region calls in this case. And of course, continual improvement. So Countdown Premium engagements don't have to end with the Go Live event. You may want to add additional features or improve the model over time, and we can help you with that through Countdown Premium. Now, I'd like to summarize what Neil had covered previously about the well-architected framework. I want to touch on a pillar that's different on the screen, and that's reactivity. So reactivity essentially refers to the drift between the desired config and your model or your workload drifting from that. And we want to be able to take corrective action. So to put this into context of our use case, we actually had the customer specifically ask us to improve the quality of the product descriptions because the model initially wasn't identifying the colors correctly. So if there was an image of a red jumper uploaded, it would identify all shades of red as red. But if they were uploading the burgundy jumper, it was still identifying it as red. And this is where we introduced human-in-the-loop feedback, where the user was able to skim through the product description and identify where the deviation is happening and revise that so it can be input into the model for the next iteration. Now, we've covered how we took the idea to POC. I'd like to welcome on stage Manish Sinha to discuss how they took their POC to production for their operator assistant with Countdown Premium. Cool, thank you. Thank you.
Thank you, Mahek. So guys, perfect timing. After lunch, I'm hoping you're ready for some storytelling as well. You saw all the architecture slides and so on. So if I can get this to move. So Georgia-Pacific. I work for Georgia-Pacific. It's been 25 years, and I love it, obviously. I'll tell you what Georgia-Pacific does. But before that, about me, I've been in different roles at Georgia-Pacific, have loved each of those roles, each of the departments I've worked in. The last 6 years or so, or 7 years, I've worked with our manufacturing community, the operators and the mills, and then focused on AI, which is the big transformation everybody's talking about. This whole reinvent is about AI and generative AI. And then something about myself, I think of myself as a performance geek. I want everything to run in real time. And my team members sometimes think that I go too far, but excuse me for that. So something about Georgia-Pacific. 35,000 people globally, primarily focused in North America, United States and Canada, 150 locations, and when I say location, I mean factories, mills that make our products. And then we support 3 US jobs in addition to those 35,000 people. Revenue-wise, $22 billion. We are a private company held by Koch Industries. But then we invest a lot of that back into the communities and our facilities and our operations, right? And again, environment-friendly, sustainability, those are pretty high areas for us, areas of interest for us, and we keep investing back into the communities. So talking about AI, talking about AWS partnership last year or the year before that, obviously we had deployed a lot of AI solutions in the last, let's say, 6 years, right? If you were able to catch one of the presentations yesterday by a couple of my partners, Roshan Shah and Carter Smith, they had a presentation on our journey from a business point of view. Why did we need it, and what did we do, or where's the value? So something along that line, what is the opportunity for Georgia-Pacific? And I won't go too much detail because you can obviously watch that session. So the labor scarcity is accelerating. Some of the people we have had in the mills running our equipment, they are close to retirement age, and there's a working age population is projected to decline, right? I mean, there's a chance that some of our factories, which are located in remote areas, closer to the wood, closer to the water bodies, they may not attract the newer generation of operators and engineers, because everybody wants to live in cities, maybe, right? So that is a problem. There's a workforce shift happening. And then there's obviously turnover. People want to work in tech companies, cleaner industries, so to say. So what we needed to do with AI and advanced analytics and all the data we collect is make sure that we can do the knowledge transfer to the newer generation of workers coming on board. And then, I don't know how many of you know how paper is made or any of our building products are made. Those are big environments, dirty environments, and sometimes a little unsafe. Like a typical paper machine is the size of a football field, right? And if you have to do inspections, it's very manual. So part of the journey here is to automate those tasks as much as possible that we can do safely. Undesirable tasks, finding people to do those tasks repetitively, right, is getting harder. From a manufacturing angle, reducing those gaps in operating envelope. And some of you may think, what's an operating envelope? Where our machines or our assets run in an optimum way. So we are producing the right amount of finished goods with at the right speed. And then the next challenge was not only finding the problems, why those gaps were increasing or we were not getting the OEE. OEE is overall equipment effectiveness. Some cases, it could be as low as 40, 50%, right? We would like it to be 80, 85%. So if we are having unplanned downtime, what are the causes? So that was part of the focus for AI. And then what is the corrective action? What should we do, or what should the personnel on the shop floor do? So those were some of the opportunities, and that has been the vision in our journey of AI and generative AI. So again, back to generative AI, 2 years ago, none of us had heard about this term, right? ChatGPT comes on in December of 2022, and then 2-3 months, everybody's all hyped up. Last year, we started this journey around mid-23. Bedrock was in beta or review. And since then, we all have seen this industry is fast evolving. Every day, there's a new announcement, a new model. A few vendors are leading the pack, right? So for us, the important part was, as the industry is evolving, we have a partner like Amazon, AWS, that we can partner with and get not only the robust operations and the environment, the infrastructure, and the know-how, but also, knowing that they are here to stay and we can bank on them so we can scale. One of the things early on we realized is a lot of the hype was around unstructured data, how you could generate text and generate videos and images and so on. But for us, a company like us, making sure that unstructured data is combined with the structured data. Neil talked about some of those topics. That is where the value is, so that the operator on the floor is not only able to see what he should go do as a prescription or what is happening right now in terms of what are the problems, but in real time. So that structured data, combining it with the unstructured or prescriptive data is a very important thing. And then, as we all know, we are all technical geeks here, some of us, architecture is the key. If we want to scale something, if we want to take it to where people will use it consistently, we'll get value out of it, we have to have the right architecture. Mehak talked so much about having the right architecture and getting the right architecture reviewed and continuously evolving. And then overall, what we want to do with our generative AI and AI is to identify those patterns and do the repetitive tasks ourselves, or automatically, essentially. And we'll get into that a little bit. So what are the use cases for GP? I'll talk about the operator assistant use case, especially in manufacturing. But we have some use cases we have deployed in production, actually, in the marketing area, in the sales and finance areas, maybe replacing some dashboards, and then in the IT operations area. And then this continues to evolve, and we get a lot of demand signals from respective departments and divisions asking for more of this, because generative AI, chat type of system makes it easy for people to ask questions in natural language. So operator assistant, which is the focus here, as Neil and Mehak talked about, the whole architecture, the evolution, and putting all the right pieces in takes time. So for us, what did we want to do? We wanted to help the operator. So who's an operator? He or she is running the machine so that we get the paper towel and the tissue and napkin or our lumber products out of the door. And to do that, the operator needs to know in real time what is happening. And if there is a problem, he knows what to go do. So it's a combination of real-time data, seeing what's happening. Because if you can imagine a football field, he or she cannot go and inspect every element of the paper machine, for example. So you need to rely on data. And then obviously, all the recipes and the books there are to say, okay, if this is happening, this is what you should go do. And there could be n number of things that could be the problems. So generative AI, along with the other AI models we have had, predictive maintenance models and process models, so generative AI gets on top of that and combines it and puts it in form of a short text maybe to the operator. Because the operator's main job is to make the finished product, the paper towel or the napkin. His job is not to go find data and research in real time what should he do when X, Y, Z, or A, B, or C happens. So the real problem we had was helping that operator. And as you can see, it has to have a real impact. It's not a science fair project. If somebody wants to do a science fair project, sure, take 2 weeks, 3 weeks, go do something, prove the technology, move on. But that's not going to change the game. What was important for us is it will show up in the bottom line. Because we have 150 facilities, and if we can improve even 2%, that is a lot of money we are talking about. And then again, we all come from an IT technology, some of us on the business side of things. It would be better if we could do it fast, so we get that value quicker. So we looked on, lower opportunity cost areas. We looked for a facility or a factory which was ready to work with us. We're hungry for, tools like this. So we had some other decisions to make. Should we buy or should we build ourselves? So this is where the speed matters, right? We want to do something, and all the models that we have deployed and all the generative AI use cases we have deployed, our foundational principle has been, if it would take 3 months, let's do it in 4 weeks. If it normally takes 4 weeks, let's try to do it in 2 weeks. Now, obviously, that puts a lot of pressure, and you cannot sustain it all the time, which is where discipline comes in. So one point I missed on the previous slide was, all of that is good, but you won't get the value unless there is adoption, which is for us to make sure that we have engaged the customer from day one, literally at the beginning of the experiment or project or MVP, whatever you're calling it. So for that, they have to be engaged. They need to give the information or knowledge which they have gained over years and years so that we can build those prompts, we can build those databases, or we can build those data structures that will support their questions, right? And then getting their feedback at every step of the way. That is the key thing for adoption and getting the value. So the very first experiment was with Amazon Support, AWS ProServe support teams. We deployed it in about 6 or 8 weeks. And honestly, I'll tell you, I'll be the first person to tell you, we did not know what Bedrock did. We did not know what LLM models to use. It was in beta, or it's in preview, right? So with Amazon's help, we were able to deploy an MVP solution 6 weeks or so. And very quickly, we engaged with the factory worker or the operator. We said, give us feedback, use it, right? And we measured their usage, of course. But then, as they liked the tool and they gave us feedback, and then we did our own evaluations, they showed us where our solution lacked. So fast failure. We didn't actually fail. Honestly, our customers, in this case, the operators, loved the tool. They could get those answers in seconds rather than going and reading a 50-page document. The documents that they have are books from the OEM, the manufacturer, or recipes, or SOPs that have been developed over the years. And that could go into 500, 800, 1,000 pages. Finding the relevant section to see what to do can take a lot of time. So they love that, right? The ability to get that answer. They also love the ability to see what's happening in real time. So those things were great. But very soon, they said, deploy it to another machine. And then another facility comes up and say, hey, deploy it to our factory. And that's when we realize these are the problems. I don't want to say hard-coded, but when you say no parameterization, essentially you're embedding prompts and logic in maybe Python, maybe whatever your programming language is, right? So we all love hard coding, don't we? Anyways, just a joke. We use some non-standard databases, not standard to Georgia-Pacific. And that's important because if you're going to scale and if you're going to have robust support from our operational teams, it needs to be something that we have skill sets on. And obviously, Amazon will support it if it's their service. We were using Kendra indexes, so for every use case, we would spin up a new Kendra index. That is not repeatable easily. We had custom pipelines, very little CI/CD. We had a source safe, version control, but no failover, for example. So those were some of the learnings from our early experiments. And then very quickly, as the demand surged, as the facilities wanted more of those, we had to obviously do some re-engineering. Even the UI had to change. The early versions of UI were in Python and Streamlit, which was not our standard skills that we use at Georgia-Pacific. So very quickly, phase 2, we went in, and like Mehak and Neil talked about, there were things that we are continuously evaluating and changing. And this is where our product team, 2 pizza teams, comes in play, right? They're dedicated to that, continuously observing, monitoring, and then making changes as we go. And then, of course, we have reviews with our architecture teams and enterprise architects and Amazon and so on. So very quickly, we said we need to parameterize. We need to store all the intent and the context and prompts in databases. That's the easiest way to make the library of parameters and all. And those databases should be standard databases where we have experience in supporting them. It could be DynamoDB, it could be PostgreSDB, and this architecture will show you. We moved to Postgres. But then you see another one, a Quasar database, right? We were in the early version, we were connecting directly to our historian, Aviva Pi, and there are some challenges over there if you want to get a lot of data in real time. A time series database like QuasarDB helps you get that real-time data, even if you were asking for a few 100,000 rows every second or every few seconds, again, against the trillions of records that you have, because it's all event data on millions of sensors, right? So performance can be a big bottleneck. So moving to those databases helped us a lot. We enabled CI/CD and DevOps practices, and then we added containerization and failover, and obviously security and governance, which is paramount, obviously, in any of these situations. One of the problems we ran into, finding the right data. Your chatbot, your generative AI is only as good as the data you feed it. So that is a problem in a company like ours, 100 years company. Some of the machines have changed, some of the facilities have changed, and the content is not updated. So how do we get that, which is something in the experience or knowledge of the operator or the maintenance engineers and so on? So we created a tool called DocGen. It generates documents, again, using Amazon tools. It translates the human experience into consumable documents, which could then be fed into the LLMs. And we have a chat interface, we have a voice interface. Some of our folks went to the facilities and interviewed those knowledgeable SMEs and asked them questions in the areas where we didn't have enough documentation or the right documentation. And then these questions, or the answers to the questions, were obviously vetted, and then we prepared standard documentation, which was then used in that. This helped us a lot in the areas where we didn't have the right content to feed our LLMs. So moving on, where we are today, like I said earlier, we have standardized our databases. We have added, different sources, SharePoints and S3 libraries and so on. We have started to optimize our cost. Kendra can become expensive if you don't use it properly. Over time, we are using one index probably for Kendra instead of 50 indexes. And then we are using AI ops techniques, ML ops techniques that we have used in other areas. Countdown Premium, again, has helped us in this area where we moved from those techniques we had used in the experimentation stage or MVP stage to a more reliable, scalable stage. So this is our chatbot. You can see that paper machine in the back. But essentially, you could ask a question. You can ask a question, whatever comes to your mind, and it'll give you the relevant answer. If it doesn't know, one thing that to remember is in a manufacturing environment, because of all the safety and other issues, you cannot have hallucination. So we had to make sure that it gives a reliable answer. So if you ask a question which is not pertaining to that machine, it'll tell you, I do not know the answer, right? But on the left-hand side, what you see is those red-marked areas. We do not want to leave it to the operator to ask the question every single time. Because the analogy I'll give you is if you're driving a car, you're the operator of the car, you're the driver. How many times would you by yourself go and ask the car, hey, is there any problem with you? You need the car to tell you if there's a problem, the tire pressure is low or some other problem. So that is what we intend to do over here. This is what the people see. Any of the big problems, it will show up. So in this case, caliper is high or the width is high, or if there is any other quality issue. Again, we also show some good things, what you're doing good. And then based on that, you can click on it, and it'll give you the relevant answer, and then you can expand on that, right? You can ask further questions. And then we do give you some sample questions that you could start with and so on. This is a feature that our operators have loved very much. So any UI has to be tuned or tweaked for the use case, and just presenting a chatbot is just not good enough, at least in our use case. We want to make it a guided experience that you can immediately go and start using, and not once in a while when you have time. If you imagine you're driving the car, I don't think you'll have the time to go ask Siri-type questions to your car. So moving on, what's coming next? What is coming is all the announcements at re:Invent. We're going to start doing some of those, right? Knowledge base, in Bedrock, agents, some of those we are going to do. We are going to optimize our costs and performance. Like I said, those are two things that we are very conscious of every single day. We will work on caching. We talked about eliminating some API calls or storage that is unnecessary. One of the things I want to emphasize here is our graph solution in-house is Neo4j, and we intend to work on graph RAG. And yes, there were some announcements in re:Invent around graph RAG coming next year. So we intend to do more of that. That has been on our back burner for the last couple of months. We expect better performance accuracy, better reliable results, and just because of the nature of graphs, right? So we intend to do some of that, and then keep working with the Countdown Premium team so we can optimize our databases, the vector databases, and agent design, and so on. So the other part, which is not necessarily highlighted here, is maybe deploying a generative AI solution at the edge. The bottom part shows you that all of it is obviously running in an AWS environment, but we may be able to take some of the smaller models and deploy it at the edge so we get a faster response to the operator at the mill. So that's something we are going to work on next year. And then what's been the impact? We have deployed 20 use cases, 6 sites, or 6 factories in about 7-8 months. We started the experimentation last December. We have about 500 users, and we intend to scale to about 50 factories or 50 sites by Q1. That's a pretty rapid speed. And then what we have observed is the weekly usage has gone up 10% every month. So we can see some benefits to our workforce with generative AI. And then how has Countdown team helped? So as is obvious, they have given us feedback on what we are not doing perfect. They have fast-tracked our model evaluation. There are so many model options. You could lose months of time trying every single one of them. And then we've got some SME support from the actual product teams from Kendra, some of the monitoring capabilities with Countdown Premium support. And then the vector database optimization, as well as making sure we use the right token sizes and so on. Those have been some of the things that the teams at Amazon have helped us with. Now, obviously, all this journey has not been easy and trouble-free. We have learned a lot. Like I said earlier, we have to get our customers from day one, get feedback, make sure the architecture is set for the long-term vision, even though you may not have the perfect architecture on day one, and then ignore the hype cycle. There'll be a new model every single day. Focus on results, quick results, but then have the architecture so that you can shift models or versions of models. And then obviously work with the cloud support teams, AWS, and then do not ignore the supportability. With this, Neil, thank you so much.
Thank you, Manish. That was great. Thank you for sharing GP's generative AI journey with us. So to wrap things up, if you want to learn more about well-architected review, the framework, and Countdown, please use these QR codes. It will take you to your landing page where you can learn more about it. If you want to engage the account teams for any of these, Countdown Premium or well-architected framework, please reach out to your TAMs, technical account managers, that can help you with that. Also wanted to share a couple of additional resources. Later today, there will be 2 sessions, the SUP302 and SEC323, who talks about managing security of your generative AI workloads. And the last 2 are done. It was one was earlier today, and was yesterday. But I just wanted to mention this because you could take a look at the recordings when they're up in YouTube. Particularly the last one, the MFG 201, Manish mentioned about the operator chatbot. And if you want to learn more about how the GP chatbot added realized business value for GP, take a look at this session. They go much more detail in it. With that, thank you so much for joining us today. And please don't forget to take the survey and let us know how things went. It helps us make these sessions better for you. And with that, thank you. Have a good rest of your day, and see you at replay today.